All right, 7.2, law of cosines. I'm going to back up for just a moment and explain to you that for a right triangle, you have several things that you can do, C, A, and B. For a right triangle, you have the possibility of using the Pythagorean theorem. You have all your relationships for the trig ratios for solving. You also have all your identities that you can use to solve right triangles. There's a lot to choose from. For non-right triangles, you have, so far right now, the law of sines. And coincidentally enough, the law of sines also works in sine of A over A, sine of B over B. The law of sines also works in right triangles. The students doing the standardized prep test are using the law of sines in the ACT to answer questions a little quicker, a little bit more efficiently. And so you can use the law of sines in right triangles and in non-right triangles. Now, if I take the Pythagorean theorem and I add something to it, that's what becomes the law of cosines. In a non-right triangle, there is no hypotenuse, correct? Okay. So you can still think of it as c squared, a squared, b squared. That'd be for a right triangle. However, through a small proof, you can derive the law of cosines, and you take minus 2ab cosine capital C. I'm stunned as why people aren't writing down the first law of cosines. Since there isn't a real hypotenuse, you can really mix the letters up. And there's a pattern that follows. So I'll wait till you're done writing the first one. I'll write the second one, and then you'll write the third one. Okay? That way I'm sure that you understand the pattern. Once people see the law of cosines, they usually don't forget them. That's been my experience. So, since there is no hypotenuse in a non-right triangle, the other possibility is you have a squared equals c squared plus b squared. What do you think comes after that? Yeah, 2cb cosine of a. That's it. That's another possibility. So it's not the letters, but it's the pattern of how everything is combined. You have the angle opposite the side, and the other two fill in. It looks a little bit more algebraic, and it is. So what's the last one going to be?
B squared a squared plus c squared minus 2ac cosine b.
Oh my God.
Nice. That was absolutely correct. And with the law of sines, you had to be given an angle to use it. So we had angle, side, angle, we used it. We had side, side, angle, the ambiguous case. We had side, angle, side that we used it. And we had angle, angle, side. With the law of cosines, normally you just use it for side, side, side. You can also use it for side, side, angle. Notice you have to be given two sides to use the law of cosines. Side, angle, side. You could also use it in the law of cosines. But you have to be given more sides for the law of cosines. You have to be given more angles for the law of sines. All right? That's why you have to know both of them. In fact, the strategy is people will use first the law of cosines if it's a side, side, side situation. And then they'll instantaneously jump to the law of sines. That's how most people work. Yes, you're using what you found in the previous answers to continue on in the problem, but that's the point you're at in your mathematics. You have to make sure you get the first one right. Yeah.
So will we still need to do two triangles if we use?
Yeah. In the ambiguous case of law of cosines, it actually works out to be, in the side-side angle situation, the ambiguous case, you actually use the quad program. A lot of people like that because it takes the ambiguity out of it, basically. Okay? There is no thought required for the ambiguous case if you use law of cosines. It's algebra, and it tells you whether there's, well, in the quadratic program, how would there be no triangles? What would you get for your answers?
4
Well, you get 0 or error, or you get 2 negative solutions. That would tell you there's no triangles. Right, quadratic program can give you 2 negatives, it can give you a 0, it can give you positives. So the one triangle would be 1 negative and 1 positive come out of the quadratic. That should make sense. Or a double root, which would be obvious. And then 2 triangles, you'd run through the quadratic, you'd end up with 2 positive solutions. And obviously you'd be doing sides and not angles. So, yeah. So it's a little bit less confusing, but the algebra will determine whether you go back to the law of sines or whether you stay with the law of cosines for the ambiguous case. Also, these expressions are a little longer to type in the calculator, but these calculators lend themselves very well to longer expressions. You can see everything instead of running out of room. So hopefully you learn to type things in with one expression. It's easier and it's better that you do that. Less chance of making a mistake, so to speak. Right? So we're moving on. And law of cosines. Like I said, I don't really use that triangle. There's the 3 situations we talked about in your textbook. Remember, this means A, B, and C. All right? So, yep, those are capital. All right, they're opposite the lowercase side. Fantastic. Moving on. Given the indicated parts for A, B, and C, what angle would you find next, and what would you use to find it? This is not a numerical solution. This is your line of logic, which is kind of scary, but nevertheless, you are developing a line of logic. What would you find first? Would you find you're given small a, small b, capital C. You still have to find lowercase c. You still have to find uppercase b and uppercase a. How would you find that? What would you find first? Yeah, you'd find lowercase c first, and you would use law of cosines. So now you have all 3 sides. What would you find next? Well, yeah, you have a choice now. You can use uppercase A or uppercase B. I will tell you what you should do and why. Because right now you're randomly guessing, and I'll give you a reason, like in a proof, of what you should do. You should always find, since you have now all 3 sides, correct? You should find the smallest angle next. Smallest angle. Well, you don't know. You're guessing which one's. How do you tell the smallest angle? Right, it's opposite the smallest side. So you should find that using the law of sines. Why would you do that using the law of sines? Is there any possibility that the smallest angle is going to be obtuse? No. There's absolutely no possibility that you can have a triangle which the middle angle is obtuse. There's no way. That clears the way for the law of sines, because the law of sines, that was one of the problems. You didn't know if the angle was acute or obtuse. So you always find the smallest angle next between what's given. All right? And then that way, there's not a doubt of what your solution is going to be. Okay? Does it make sense? I hope so. On this one, this is side-side angle. What's the first thing you have to find? Yeah, you have to find side A. And you'd use that using the law of cosines. And is that the ambiguous case? We do know it's the ambiguous case because it's given a side-side angle.
Well, I mean, we don't know.
Well, we don't know if there's 2, 1, or 0, right. But the law of cosines we would do, and we would definitely use a quadratic program. I would. It's the best way of doing it. Okay? So, yeah, you'd find A, then once you get that, again, what would you find next?
Smallest angle.
Yeah, you'd find the smallest of the 2 angles left, and that way you, so you find A first, and then second you find the smallest angle using the law of sines. Okay? That would be the best approach and the safest approach. Safest. Oh, yeah. All right, here we go. It is time. You got your calculators. It is time to demonstrate your ability to use the law of cosines because it is massive. Let me see if I can boot this up.
Can't be.
Yeah, I don't know what that does. Yeah, I know what it does. I don't know why it's up there all the time.
Maybe it's game.
Could be.
Maybe it's
View. There we go.
It's
All right.
important to-
So here's A. Here's B. Here's C. My picture rarely changes. C is 45 degrees. B is 10.0. That usually tells you how to write your solutions. Okay? And A is 15.0. That means they're rounding to the nearest tenth. Okay? Now, we have to find what first? Small c. Now, watch very carefully. C actually equals the square root of a squared, which is 15 squared, plus 10 squared minus 2 times 15 times 10 times the cosine of 45 degrees. That's how you would type it out in one solution. It looks difficult, but it's actually very easy. Because you have this calculator, you can read everything. So, you take the square root. You already have, on this one, you have an automatic parentheses. 15 squared plus 10 squared minus 2 times 15 times 10 cosine 45. Need a double right. You need one right for the cosine and one right for the radical. So, hopefully you end up with, so yeah, 10.6. So C equals 10.6. That was not difficult, not even in the slightest. So C equals 10.6. You can use the law of cosines again if you like to find B or A, but you have to use the inverse. Some people feel a little bit more comfortable using the inverse of cosine, or sine instead of cosine. So which one would I find next? Would I find angle A or angle B?
B, because it's the next smallest.
Right, I would find B. In fact, I know B is going to be less than 45 degrees. So, yeah, so B is actually going to be equal to the inverse sine. B equals the inverse sine of, oh, we can. I didn't know you want to take 2 steps to do it.
Or you can just use the sine one step.
Well, if I wanted to, I can write it like this. Sine of B over 10 equals sine of 45 over 10.6. And then I can take B equals the inverse sine of 10 times sine of 45 over 10.6. And you're going to have 2 sets of parentheses again. Okay? So,
Are you in degrees or in?
well, then you typed it in wrong. Okay? Well, there it is on the screen. Go through every parentheses and square. Well, make sure you're not using a negative sign where a minus sign should be. Okay? So, the next one, inverse sine, 10 times the sine of 45 divided by 10.6. 41.8? Okay. So that means that this is 41.8. And how do you find A?
180
Yeah. 180 minus 41.8 minus 45. So A equals 93.2. Okay?
Hold on, what was the 40? What was the last one?
I am.
I think maybe my kid.
Oh, which
We typed in 45, you typed in 48. Okay? So that's how you get all 3 of those. Any questions? 10.6, 41.8, Sine 3.2? 10.6, 10.6. Do I have all? Oh, right here.
Yeah. Did you have a free?
41.8. No, I didn't. I was up, so I thought I'd say it for a little bit.
Next one?
No, close.
Frame rate.
No, closer. This one.
Number 12. Frame rate.
All three sides. We haven't had this situation before. Now I'll tell you your strategy on this one.
We can do it though.
The strategy is to use the calculator to your advantage. You only use a quad program on this side angle. This is clearly all three sides. So that's not the situation here. Here's A, here's B, here's C, 10, 15, and 12. On this one, when you're given all three sides, there's two strategies to follow. One that's very sound, very good, one that's okay. The one that's very sound and very good is, if you're going to use the law of cosines first, law of cosines, and you're going to use the inverse button, you have to use the inverse cosine button, right? If you're going to use it, you should find the biggest angle. Do you know why if you're going to use this button, do you know why you should find the biggest angle? The inverse goes between what two quadrants? First and second. So, 0 degrees is over here, and what's over here in the second? 180. Inverse cosine will tell you if the biggest angle is obtuse or acute. There's no guessing game like there is law of sines. It will tell you if it's obtuse. It will tell you if it's acute. That way you don't have to worry about what kind of triangle it is. The law of cosines does it for you. So whenever you're using law of cosines, you want to find the biggest angle first. You don't have to do that. You can pick any one you like, then pick the next smallest to find the law of sines. But I always like to use that biggest one first. So in my notes, when I do these problems in my work, I will go for angle B first. You don't have to do that. You can go around the corner, come around the other side, and see if we end up in the same place. That's fine. Okay? But I'm going to go with the biggest side first because that's my reasoning. So that means, and it also tells me how to set it up. If I'm looking for angle B, what side is by itself on the left-hand side of the equal sign? Yeah, 15. So I have 15 squared equals, there's the B squared, minus, or equals 12 squared plus 10 squared, minus 2 times 12 times 10 cosine of B. All right? Now, I said you have this big fancy calculator. You should use it. When you're solving this, the reason people do this is you're not writing a program. You can recall all these entries, right? So you can recall this and find the next angle by just going up and putting in the right numbers. Watch very carefully. If I want to get B by itself, by algebra, the order of operations say the first thing I do is what? Yeah, I subtract those two numbers over. And what do I do with these three numbers, the negative 12 and the 10 and the 2? You divide those. Then how do you get rid of the cosine? Inverse cosine. So, B equals the inverse cosine, and you're going to need a double set of parentheses. That parentheses for the inverse cosine. This parentheses for my numerator. 15 squared minus 12 squared minus 10 squared. That's the first thing you said to do was to subtract. Anything not multiplied but added gets subtracted first when you're solving. It's the inverse. Then you get another set of parentheses divided by this. Because these are all multiplied together by cosine, so the only way to do multiplication is division. So you divide by negative 2 times 12 times 10, and you close that one off with the denominator. And don't forget, you got a parentheses back here for your inverse cosine. Yes? Well, I'm just solving for B. I'm moving it to the other side away from B. I could, but then I have to add everything over here. I'm trying to get B by itself. This letter, B. You can, but I like to do it one step. That'd be like, well, you can do it like that, sure. So, 15 squared. Oh, I forgot my first thing. Inverse cosine. Parentheses. 15 squared minus 12 squared. A lot of times these arguments, even in calculus, they have problems typing things into the calculator that are large calculations. This isn't a large calculation, there's just a lot of things to it. Negative 2 times 12 times 10. There's my denominator. There's my inverse. 85.5. Okay. So, B is equal to 85.5 degrees. Yeah, you can. You can either use the law of cosines. You can do this again and just change the 15, the 12s, and the 10s, or you can use the law of sines. Yep. One something way off? Here, let me take a look. Oh, this is 2 minus signs. You're subtracting 2 things.
Oh, okay.
Okay? There you go. All right. Now, are we doing law of sines or law of cosines again? Law of cosines? Which one are you doing, John? Go ahead. Lead the way. Which one? If you're going to do the law of sines, there's an angle you're supposed to pick next to find. You can do C or you can do A. I would do A. It's opposite the small side. Now, you already know the biggest angle is 85.5, but in case you made a mistake, this will help you find it. So you have the sine of A over 10 equals the sine of 85.5 divided by 15, right? Now, in my calculator, should be the law of sines somewhere. I've already done it, haven't I? Let me put this in right here, over here. And law of sines. Second enter. Second enter. There it is. Law of sines. So I can put in the 10, the 85.5. Oh, the 10's right there. Nice. The 85.5. 85.5 divided by 15, I believe. 15, 0. Anybody get 41.7? Nice. That we got, John? Did you punch it out? Good. All right, so it's 41.7 for A. What is C going to be then? What is it? 52.8. Okay? So, questions on that? Once you learn to type in expressions into this calculator, it's going to make it a lot easier. You don't have to keep track of where you are in your calculations where more mistakes can be made. Okay? That's why so many people require these when you go on to school. Okay?
Should we put the law of cosines on our...
Probably, in case you ever, yeah, this is used in calculus. I'd put it on there. Surveying. Does anybody know any surveyors? Yeah, all right, here we go. Surveying. Anybody talk to those surveyors and tell them we were talking about them in class?
No, I don't.
To find the distance between points A and B, a surveyor chooses point C. So you're looking for the distance between A and B. That's small c, isn't it? You're looking for that distance. A surveyor chooses a point C that is 420 yards from A. 420. I have no idea if I'm going to draw this right, but I'll give it a shot. And 540 from B. 540. If the angle AC, oh, this must be C down here, capital C. If the angle ACB has 63 degrees in 10 minutes, 63 degrees in 10 minutes, approximate the distance between A and B.
We could do
Could you use the law of sines in
You
this?
could, but it's the rated R one, right?
No, it's not.
That's
So side angle move.
Yeah, so you couldn't use the law of sines on this one. You don't have an angle opposite the side to start the ratio. That only leaves one choice, which is the law of cosines. Which letter are you looking for? C. So it's very easy to type out. C equals the square root, parentheses, 420 squared plus 540 squared minus 2 times 420 times 540 times the cosine. Oh, that's a lot of typing. I'm going to erase that and start over. Yeah,
Could you just take?
I'll do this. No, I would do this. C equals the square root, parentheses, 420 squared plus 540 squared minus 2 times 420 times 540 times the cosine, and this is how I would type it in, parentheses 63 plus 10 over 60. There we go. Nice, you should be a surveyor. 513.1. Anybody else get that?
I got it.
Yeah.
Fantastic. Huh?
The unit.
I thought it said yards. Let's check.
Let's check. We want to make sure we use most.
It said yards. So C equals 513.1 yards. Okay? That punch out on everybody's calculator? No, it just said find the length distance between 2 points. All right? That's good. Law of cosines. A quick brain break.
Yes.
Last time we did a brain break, my video crashed. Let me see what's up.
Video crashed yesterday?
Yes, it did.
Yeah, I know you didn't have the
Yeah,
some kinds of videos break on.
I know. They're on my desk. I have to photocopy them. I'll work on them. All right. Trig. Oh, wait a minute. Brain break. Where'd it go? I don't even know if we have a brain break for today. All right. All right, we're just going to pick one and see if we did that one. We're about right about. Let's see, the last one we did had the thumbs going. And pinky? What's a partner one?
Number one.
Huh? We did thumb and pinky last time, didn't we?
Yeah.
So we got to do the next one. Touch your fingers behind your back.
Did that one.
Yeah, we're doing it again. I told you there's only so many.
Why don't you start making them drum?
Why?
Good.
I'm a little busy. There we go. See, nobody else could pull that off in the whole school.
What? This?
Yeah, putting it up there like that. Well, so the one kid, I know a couple kids that can do both. Pretty amazing. Now, every class was like 3 or 4. So stand up, reach one arm straight in the air, move forward and backward to stretch your shoulder. Don't hurt yourself, that's what that means. Now bend your elbow so your arm goes behind your head to the middle of your back. Move your elbow to the back and forth. All right.
I can touch them, but
All right. That one I can do.
I can do these.
Yep. And the other one. Work it out a little bit. Stretch it out.
Got this.
Not even close. Okay. Not even close.
I got this.
Nope. That's not even close. Not even close. All right. Take your hands. Reach for the tiles. Stretch the weight up. Oh, there we go.
Let's do one of these.
And that's about it. Okay. Oh, see, that feels good.
Does.
Also, with all of you like that.
I can't crack my back
Oh
anymore.
my gosh.
All right. Here we go. Let's see if you can do this one on your own, start to finish, and get the right answer quietly. Give this one a go.
I thought it was another brain break.
I'll give you a minute and a half. Yeah, a minute and a half. If you take longer than a minute and a half, then
Adios, amigos.
I'll do the balloon pop. No, I won't. I'll do the guitar. Nice.
Someone would find the Wookiee noise.
There. Minute and a half. You should be able to do this in a minute and a half. It's in your book. Make a picture. Label the sides. Nice. All right. It was. Hopefully you knew you were finding angle A.
Got 25.
And you took, hopefully you took 180 squared minus 350 squared. It says the smallest angle.
Squared minus 350 squared minus 420 squared.
You're trying to find the angle between 420 and 350.
I just scrolled back.
Right. So, divided by -2 times 350 times 420. Close off with the denominator. Close off with the inverse cosine. 25 degrees? 25 degrees?
Okay, it must be right.
Nah, some people aren't getting the same answer. I'm holding on.
I got 75.
75 degrees. Two answers on the table.
Oh, no, never mind.
I was gonna say,
Never mind.
I'm gonna let you admit wrong.
25?
24.5.
What happened? All right.
Yeah.
350 times 420. Nope. Why'd I get 155? Oh, I got two negatives. There you go. Delete. There we go. 24.5. Oh, 25. Yeah.
180. Hold up.
Hold up what? 180
180
squared minus 350 squared minus 420 squared? 25 degrees. All right. Quiet, please. One more. Here we go.
Hold on.
What?
I was just double checking what I did wrong. I get bored when I'm sitting here, okay? I think I did it right. I don't know, maybe I just didn't.
All right, here we go. Try this one. This one, you're going to have to use the unit circle instead of the bearings we talked about yesterday.
Did I write down right?
This should be, that number does not appear in that product, so it should be 350 and
Oh.
420.
Okay.
Okay. Airplane flies 165 from point A in the direction of 130 and travels in the direction 245 for 80 miles. Approximately how far is the plane from A? And here, obviously, a picture is crucial. So, 130 degrees. A. Where would 130 degrees be if you're looking at the unit circle? Which quadrant?
Second.
Second. So here's my reference point, 0 degrees. Okay? So plane flies 165 miles, so this leg would be 165. This angle would be 130 degrees. So far, so good? Great. Then it says, then it travels 245 degrees for 80 miles. So you're at this point, you're at the end point. I don't know, I'll just call it point B for fun. At point B, you travel 245 degrees. Again, my reference point has already been decided to be the positive x-axis. So if I look over here, 245 is in which quadrant? The third, right? So I would go this far for about 80 miles. This angle right here is 245. Approximately how far is a plane from point A? So this is the length you're looking for. I'll call that C. So you're looking for lowercase b in my picture. B equals, well, this isn't too bad. I know the two sides are, it's a square root of 165 squared plus 80 squared minus 2 times 165 times 80. Cosine of what angle? Right. And what's the measure of angle B?
Are we looking for the measure of?
We're looking for the leg C.
Oh, okay.
Oh, wait, okay, I see.
Approximately how far is the plane from A? So you're looking for this green leg. We don't know the measure of angle B. Well, I hope so. Knowing what? That's 245, right? Go ahead, line of logic.
Parallel lines, can you do that thing?
Maybe.
You know it's only.
So this angle would be what? If that's 130, this one has to be
50.
50.
So then 50 plus 245 minus 360 is.
There you go. What is 50 plus 245?
310. No, 390.
295.
Yep.
So, if the whole thing is 295, what's this? 65 degrees. That is the measure of angle B. Good. And all you have to do is type it out. So yeah, you're going to have to remember some geometry, and that is part of it.
Two parallel lines cut by tangent.
Yep. B equals square root. Could you? Yeah, absolutely.
You're solving for little b, bro.
You're solving for small lowercase b, correct in my picture. Plus 80 squared minus 2 times 165 times 8 times the cosine of 65 degrees. 80. There we go, 80. What is it? Perfect. So it's 149.9 miles. So yeah, you're going to have to do a little geometry, which isn't too difficult. I think that will take us... Oh yeah, we're starting with this one tomorrow.
All right, let me go. Writing that down.
I like that problem. Look at it. Most people just walk away from it, not us.
Never retreat, never smoke.
23.
What's that say? Oh, 65 degrees.
Page what? 1 through what? 546? 1 through 23 odd.
546.
Yep. Fantastic. Now, hopefully this won't crash today like yesterday.